Question 2. Physical Science Paper 1, Year 2023. This scenario is about these blocks, whereby this block is released from this height of 1.5 meters to hit the ground with a velocity of 3.41 meters per second. Take note that the system was initially stationary. Since it was initially stationary, that means initial velocity is 0, and this 3.41 meters per second is final velocity if you're going to refer it from rest to motion. But if you're going to refer it from motion to the ground, this 3.41 can be initial and final velocity can be at the ground where it is 0. Then the instruction is, you must show by means of calculations that the acceleration of block B is 3.88 meters per second squared. This block B is 7.5 kg in mass, where this one, its mass is unknown yet. To calculate this acceleration required, we are using this equation of motion. We're going to use downwards components where the velocity and height is positive. We fill in this equation the data that we are given. Final velocity here, initial velocity here, and height here. Acceleration is what we are to prove. So, further step, we get the magnitude of acceleration is 3.88. The unit is meters per second squared. But you can use upwards components. Velocity will be negative and height will be negative, which gives us the same magnitude of acceleration. Therefore, it is proven. In the following question, we have to illustrate the force diagram of block B after it is released. So, the force acting on this block is upward force on the rope. This force points upwards and weight facing downwards. Now we have to calculate the value of this m on this block. We are going to apply Newton's second law of motion, where we are using this formula. Because this block is moving up, that means tension is greater than weight force. Net force of this block is made from tension minus weight force. We equate it with mass of this block and acceleration of the system, that is this 3.88. So, because this expression has two unknowns, we leave it so for now. Let us minimize the number of unknowns from this equation by calculating the tension using this block B, because tension on this side is the same as this side. We apply Newton's second law of motion. On this block B, the weight force is greater than tension, which means that net force on this block B is made of weight force minus tension force. All equate to mass of block B and acceleration of the system, which is this 3.88. Mass is 7.5, and the tension that is what we are calculating now. And weight is 7.5 times 9.8. By doing so, we get the value of tension is 44.40 newtons. We come back to this expression. We replace the tension. Now, only this m is unknown, which is simply getting us the value of m to be 3.25 kg. To calculate the maximum height reached by this block, we firstly calculate the height of the block because they are not in the same size, which means they cannot hold the exact same height. We apply this equation of motion. We are using the block in motion and on top. That will mean this 3.41 is initial, and final velocity is on top. In that case, the final velocity is 0 as it is referred from motion to top. On this acceleration, we use gravitational acceleration, which is 9.8. By doing so, we get the height of this block to be 0.59 meters. So the exact maximum of this block will be provided by adding this 0.59 meters to this 1.5 meters, which gets our maximum height to be 2.9 meters. Question 3. Physical Science Paper 1, Year 2023. This question is about free fall, where the ball is dropped from the top of a building which is 15.2 meters high. and we were told that after the ball fallen 3.2 meters, ball B was projected, and they fell at the same time on the ground. Take note the balls were initially at rest, meaning that initial velocity will be 0. The first instruction is to define free fall. Free fall is the motion that is under influence of gravity, weight, or gravitational force. In the following question, we have to calculate the time ball C takes to hit the ground. We're going to use this equation of motion, whereby we are using downwards components as it is moving downwards. But you can use upwards ones as long as you put the correct signs. We put the height here, initial velocity here, the gravitational acceleration here, and time is what we are looking for. This part is 0 because of this initial velocity. We get the time the ball C takes from top to hit the ground to be 1.76 seconds. Now we are instructed to calculate the magnitude of the velocity with which ball B was projected from the ground. Remember that the ball B was projected when the ball C has fallen 3.2 meters from height of 15.2 meters. And both balls hit the ground at the same time, which means that the time ball C takes from this height to hit the ground, that time will be the same for both of balls. So, we will use this equation to calculate velocity, but we don't have time for how long the ball from projection to hit the ground, since they hit the ground at the same time, which means we must have time for ball C from 3.2 meters, since we have time from 15.2 meters to hit the ground. Let us quickly calculate time for ball C in this 3.2 meters. We use this equation. On the height we put this 3.2, and this part is 0, because initial velocity is 0. We get 0.81 seconds that time from top, then we minus this 0.81 from 1.76 seconds, which gets us 0.95 seconds, and remember this 0.95 seconds is for both balls to hit the ground. Now we fill in this 0.95 on this equation to find ball B's velocity. For the sake of knowledge, when it is moving downwards, initial velocity and gravitational acceleration are positive. As for this scenario, final velocity is 0. By doing so, we get initial velocity for ball B to be 4.66 meters per second. The last question instructs us to draw the graph to illustrate ball C and ball B on the graph. So the graph will have distance as height on the y-axis and on x-axis will have time. The ball was dropped from 15.2 meters higher and took 1.72 seconds to the ground. And also ball B starts at 0.81 second projected upwards, takes 0.95 seconds to hit the ground when we add 0.95 to 0.981 seconds. That gives 1.76 seconds. That where ball B landed. Question 4. Physical Science Paper 1, Year 2023. This scenario is about these two trolleys, whereby this first trolley is moving with 0.4 meters per second to collide with trolley B, which is stationary. That is before collision. After collision, they lock together and move to the right. Our duty is to calculate the velocity of these trolleys immediately after collision. When the objects collide and after collision, they stick together like in this scenario. Such a collision is called an inelastic collision. To calculate this velocity that we are instructed to calculate, we apply linear momentum. Total momentum before collision is mass of this trolley, times its velocity plus mass of this trolley B, times its velocity. Momentum for trolley B before collision is 0 because it was stationary. We equate it all with total momentum after collision, which we combine masses of trolleys, times their unknown velocity. Inelastic collision combines masses of those objects involved in that collision, but take note that they are combined after collision, not before collision. In this expression, only this velocity is unknown. In further steps, we get the velocity of trolleys when locked together to be 0.23 meters per second. On this following question, we are instructed to calculate the force exerted by this trolley on trolley B if the collision time is 0.2 seconds. We apply the impulse formula. On the impulse formula, we put time here, a mass of this trolley here, initial velocity here, and final velocity here. Only the force is unknown in this substitution. So, we get negative 61.2. That is absolute 61.2 newtons. That is the force exerted by this trolley on trolley B during collision moment.